Good morning, and today we're going to look at functions and mappings. A function or mapping from a set A to a set B is a rule that relates each element in set A to one and only one element in set B. Sets of element in set A is called the domain, which is the input. Sets of element in set B is called the range, which is the output. So the input numbers we often think of as x's, we have to know that that's what we mean by the domain. And the output numbers we often think of as the y's, and we have to know that that's what we mean by the range. So domain is the input, range is the output. Let's look at an example. F of x is equal to x squared plus 3 has a domain as given, -1, 0, 1 and 2. Find the range. Now, that's another way of saying that for the function, if the x values are -1, 0, 1 and 2, what are the y values? What is f of x? Okay, so we put x equals -1 into the function. F of -1 is equal to -1 squared plus 3, which is 4. F of 0 is equal to 3. F of 1 is equal to 4. F of 2 is equal to 7. So the range, all of the answers, all of the y's, if you like, would be the set 3, 4 and 7. A function can then be described by a formula for f of x, as we've seen here, an arrow diagram, as you may remember from the past, and I'll show you in a future PowerPoint, and also a graph. Now this one's an important one. We're asked to find the largest possible domain. If we're asked for the largest possible domain, we have to state the values of x that will ensure the denominator is never 0. Okay, so here's some examples. Okay, so what would be the possible domain for this function? What could be the largest possible domain for the function? Okay, so it could be all values of x. But what can x not be equal to? Well, the denominator of a fraction can never be 0. So x cannot be 0, or you'll have an 8 divided by 0. But you can have an 8 divided by anything else. So you would write your answer like this. The domain, the values of x can be any value of x where x is not equal to 0, and x is a member of the real numbers. X is a member of R. What if we have a slightly more complicated one, where we have h of x is equal to 3 over x squared minus 4. So x can be any value apart from anything that would make this denominator 0. Now have a look at the denominator and see if it can be factorised. This one can be. This is a difference of 2 squares. Square term. 4 is a square number. It's 2 squared. Difference in between. A difference of 2 squares. Okay, so we have x plus 2 and x minus 2. Now if we were to take this over to the side and make each of these equal to 0, it's easy enough to do in your head, so we don't have to write that working out. But x plus 2 being equal to 0 would lead you to x equals minus 2. X minus 2 equals 0 would lead you to x equals plus 2. So x can be any number, but it cannot be -2 and it cannot be +2. And x is a member of R. So you look at each of them and you work out what the denominator cannot be to make it 0. We can't have a 0 in the denominator. So what value of x can we not have, because that would give us a 0 on the denominator. Okay, and x can be anything else bar these numbers here. Now these parts here are the really important parts. That's what we need to see in your answer. We're quite forgiving in the higher course in that we don't need to see the full set builder notation, but we do need to see this middle part written, what x cannot be equal to. Okay, so now we're ready to look at exercise 2b, and we're going to do questions 3 to 7. And as always, ask your teacher for any help, and good luck and take care.